These first four questions were just asked to multiply. That the method we use will be different on the first two than it is on the last two. Okay, so in these first two, it is just a monomial, a constant or a monomial like 2x multiplied by a polynomial. So all we're going to do for those is distribute. Okay? So we distribute the -3 to all three terms. We get -12x squared plus 15x minus 6. No like terms, so we're done with that one. Number two, again, it is just distributive property because there's only one term outside in front of these parentheses. So 2x times x and 2x times -5. That gives us 2x squared minus 10x. Numbers 3 and 4 now, we have binomial times another binomial. So for these two, we will use the FOIL method. So first, x squared, outers, positive 3x, inners, negative 7x, and last, negative 21. We do have like terms now, so we need to combine and end up with x squared minus 4x minus 21. And last one here, another FOIL. First is 2x squared, outers, negative 12x, inners, negative 9x, and last, positive 54. The like terms in the middle, so we have 2x squared minus 21x plus 54. Next set of problems, we're going to factor. Okay, so 5 and 6 are just binomials. So we know we only have two methods for trying to factor binomials. We could look for a GCF, and then after that, whether we had one or not, we should still check to see if it's a difference of two squares. Okay, so in the first binomial here, there is a GCF. 7 goes into both 28 and 21. So we remove that, we undistribute 7. 7 times 4x would give us the 28x, and 7 times -3 results in the -21. We should look at the binomial that remains in the parentheses to see if it could be difference of two squares. It is a difference, but we do not know the square root of either of those terms, so we are done. Number 6, there is a GCF. We could take out a 4 and also an x. So 4x times x is 4x squared, and 4x times -2 is -8x. And again, when we look at x minus 2 in the parentheses, it is not a difference of two squares, so we are finished. 7 and 8 are trinomials, so difference of two squares is not an option. We need to look for GCF and then try our little magic x factoring method. So number 7, there is no GCF, so we're ready to jump right to this magic x. We have a product in mind of -36 and a sum of 5. Since we have a negative product, we need one of each sign, and they need to be different by 5. So that would mean we want positive 9 minus 4 to get 5. Our factors then are x plus 9, x minus 4. And lastly here, number 8, we do have a coefficient in front of the x squared, so that makes it a better chance of having a GCF. Definitely need to look. We don't have one, though. That also changes the method of factoring. We still make our x, but to get this desired product, I need to multiply the a times the c. So 5 times -2 is -10, and my desired sum is -9. To get a product that's negative, I need one of each sign. They need to be different by 9. So that's positive 1 minus 10. Those are not the factors, though. Those are just the numbers that I use to split up the -9x. So I'm going to rewrite this as 5x squared minus 10x plus 1x minus 2. To look at those first two terms, 5x squared minus 10x, I can remove a 5 and an x. So 5x times x to get 5x squared, 5x times -2 to get -10x. Now, there isn't really a GCF in 1x minus 2, other than just the number 1. But we notice it's already, these two terms already match the parentheses that I want to match down here. So what we do in that case is just say, we're taking the GCF of 1. So 1 times what is x minus 2? Well, 1 times x minus 2. Our parentheses now match like we're expecting. So our factors are x minus 2 and 5x plus 1. All right, and lastly, we just are going to add and subtract some polynomials. So for addition, we know the parentheses mean absolutely nothing to us. We're just going to jump right into combined like terms. So 2x and negative 12x is negative 10x, and then I still have a plus 7. Negative 6x and 7x is 1x. 1 and negative 3 is minus 2. X squared and negative 3x squared is negative 2x squared. Negative 5x and positive 2x is negative 3x. And then don't forget about your negative 4. And 12, negative 8x squared and 14x squared makes 6x squared. 3x and negative 5x makes negative 2x. And then our constants, negative 9 and negative 1, negative 10. For the last 4 here, we're going to subtract. And the subtraction problems have one extra step. You need to distribute that negative sign into the parentheses following it. So that changes all the signs. 5, then we have minus 4x plus 8. Combining like terms, 5 plus 8 is 13 minus 4x. Or I guess in standard form, negative 4x plus 13. Number 14, distributing the negative, I rewrite as negative 5x plus 12 plus 3x minus 4. To see my like terms, negative 5x and 3x is negative 2x. 12 minus 4 is 8. Number 15, distributing the negative, I will rewrite as 9x squared minus 8x plus 4, and then I will have minus 6x squared and plus 11. 9x squared and negative 6x squared is 3x squared. My negative 8x, I don't have any other x to the first terms to combine with that, so I'll keep it negative 8x. And then 4 plus 11 is 15. And 16, again, distributing the negative sign, allows me to rewrite this 7x squared plus 15x minus 2, and then it turns into minus 7x squared plus 18x minus 3. Like terms, 7x squared minus 7x squared cancels. Those are gone. 15x plus 18x is 33x. And then minus 2 and minus 3 makes negative 5. And the very last section asks us to divide. Now, we haven't done a lot of these, but to divide a polynomial, a binomial or a trinomial by a single term, your first step should be rewrite this as separate fractions. So 15x minus 45, all divided by 5, should be rewritten as 15x divided by 5 minus 45 divided by 5. And then you simply reduce the individual fractions. So 15x divided by 5 is 3x. 45 over 5 is negative 9. 18, we write 18x squared over 3 plus 9x over 3 minus 30 over 3. So first one simplifies to 6x squared. 9x divided by 3 is 3x. And negative 30 divided by 3 is negative 10. 19, a binomial divided by a monomial. So we have two fractions, 8x squared over 4x plus 12x over 4x. Reducing here, 8 over 4 is 2. And then x squared over x, we're talking about going all the way back to first marking period when we were learning the laws of exponents. When you were dividing powers with the same base, you subtract the exponents. So here we have an exponent of 2. This is really a 1. 2 minus 1 is 1, so x to the first. 12 over 4 is positive 3. The x's cancel. So 2x plus 3. And last problem, number 20. Again, we're going to result in two fractions. We have x to the third over x squared minus x squared over x squared. Now, again, using the laws of exponents, subtract these. 3 minus 2 is 1, so x to the first. Now, x squared over x squared, they do cancel, but that does not mean that term is gone. When you are canceling top and bottom on a fraction, if everything is canceled out, the result is 1. So x minus 1.